Hello everybody and welcome to this evening's Easy 11 Plus live lesson. I'm afraid I don't have a cat with me this evening. I do apologise to the cat fans out there. Hello to everybody in the comments. Hello Elizabeth. Hello Topsay. Lots of familiar faces. Hello Tracy. Brilliant to see you all. Don't forget that I teach as well now. You can join my classes on Zoom. Have a look at my website to find out more. I'm going to be teaching one in just under half an hour, so I better get cracking with this evening's lesson. So we're looking at some really, really tricky maths, but I must say it isn't quite as tricky as I hyped it up in my lesson emails. There's another very similar looking question in another past St Paul's Girls' School maths paper that I think is considerably harder than this. This is hard, but kind of achievably hard for any of you, I think, if you just open your mind a bit and don't let yourself be put off by the fact that this is testing maths that you haven't specifically studied. By the way, isn't my hair incredible this evening? Right, okay, so we're told that ON is the value of the first n odd numbers multiplied together. So that's O for odd. The first n odd numbers, so that's whatever number of odd numbers. So if it was O3, as in the example, oops, I've skipped to somebody's work. Apologise to that person. That's for my lesson afterwards. Oi, what's going on here? What is going on? There we are. No, that's the wrong thing. That's somebody's work. Again, my apologies to this person. What on earth is up? Right, I should be able to write on this. What's happening? Why can't I write? Stop showing that letter. Stop showing that letter. Stop showing that letter. And whenever I try to scroll, right, I've got a buggy browser here that I'm using. Fantastic. Okay, we come to here. We make sure that writing is turned on. It is turned on. So what is happening? And we get rid of this rubbish and we make it full screen. Okay, now we try again. Good, and now it works. So what was I saying? Technology. What were we saying? I was saying that the first 3 odd numbers multiplied together are 1 times 3 times 5. The first 5 odd numbers are 1 times 3 times 5 times 7 times 9. They're the odd numbers. We're missing out the even numbers. That's what makes them odd numbers, in a way. And En is the value of, what could that be? The first number of even numbers. So if it's E6, we got the first 6 even numbers, 2, 4, 6, 8, 10, 12, and we multiply them together and we get a very large number, 46,080. Take time with this information at the top of an exam in order to make sure that you fully understand what you're doing. If you don't, you're going to be really stuck when you actually get on to answering the questions. So if O5 is 1 times 3 times 5 times 7 times 9, and that's 945, what's O6? Well, O6 is all of this stuff times by the next odd number, which is 11. So we do not need to work it all out from scratch. O6 equals O5 times 11. And O5 was 945, so it's 945 times 11. So we just need to calculate this. So we're doing 945 times 11. I haven't left myself enough space there. Good work, Robert. Let's get rid of the O6 equals, just for the sake of giving myself space. So let's do 945 times 11. Apologies for the messy presentation. So 5 times 1 is 1, 4 times 1 is 4, and we got 9, and then we start with a 0 on the next line, and then we got the same thing because it's all times by 1. Now we just add them together, so we got 5, 9, 13, and 10. So we got 10395. Oh, for heaven's sakes. Not going well with the tech today. 10395. And that's our answer. Don't forget to write it in the answer space. So we just took what we were told in the question, that O5 is this. O6 is times by the next odd number. So we just took the answer, 945, and times it by the next odd number, 11. It's actually quite straightforward when you think about it like that. But you just need to be logical. Now here, what's the remainder when O50 is divided by 15? So the first 50 odd numbers multiplied together. Now, if you're not thinking, you'll try to work out O50. But I'll give you a tip. It will be a number of such vastness that none of our brains are able to comprehend it. You're not going to be able to calculate O50 in the exam. Even if you're preposterously good at multiplication, you're not going to have time. That is not how you do it. let's think about these numbers. So 050 is going to be 05 times 11 times 13 times 15 times 17 times 19 times 21 and so on. If it's divided by 15, well, what do we notice when we look at 05 up here at the top? We notice that it contains 3 times 5, which is 15. Anything from 03 and beyond, you can see it here in 03, is 15 times lots of other things. And anything that's 15 times lots of other things is going to divide by 15. In other words, it won't have a remainder. We can actually just write the answer in here. If we wanted to show a bit of working, I suppose we could say, we could write something like this. Times 3 times 5 equals times 15 times so therefore there's no remainder. That's the kind of working you could show if you wanted to show working. What's the remainder when 100 is divided by 2? Well, anything that's which is timesing odd numbers together, is going to be odd. An odd times an odd is an odd. Okay? So the answer is always going to be odd. And what's the remainder when you divide an odd number by 2? Of course, it's 1. I'm not even going to bother to write working for that. That's just testing your understanding that this is an odd number. What is the remainder when E100 is divided by 3? So the first 100 even numbers. You could get very puzzled on this, but think about what we did up here when we were looking at 050 divided by 15. We looked at which things were inside that number. Is there a 3 anywhere there? Even numbers. So we look at this. E6 is what we got here. Now we're looking up there. Now these are all even numbers. There's no 3 there. But are there any multiples of 3? We've got 6 and we've got 12. So there are things in here that have 3 as a factor. So this is a bit like saying 2 times 4 times 2 times 3 times 8 times 10 times 4 times 3. So 3 is inside this number. It's timesed by 3 as you go along. Therefore, there won't be any remainder. We can just jot that in, times 6 times Therefore, and 6 divided by 3 equals 2. So therefore, 3 is always a factor of these numbers. So the remainder will be 0. Okay, right. So that's really helpful. Oh, you can see the box around me. Let's turn up my light. You can still see the box around me. That's not supposed to happen. It's because it's going dark outside as I'm doing this. And so the light is changing. Fiendish darkness. Okay, right. And now we carry on to the next page, which is likely to be a bit trickier. And this is where you start to use some of the concepts that you've understood from the first page. So you're told that n factorial, that's what the exclamation mark means, n factorial, is the value of the first n counting numbers multiplied together. For example, 1 factorial is 1. 2 factorial is 1 times 2 is 2. 3 factorial is 1 times 2 times 3 is 6. So this is a standard mathematical way of writing this mathematical idea. 3 factorial is 3 times 2 times 1. 10 factorial would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's what a factorial is. So if somebody said, what is 4 times 5? And you went, that's easy. Obviously, it's 20. And you wanted to show it was 20. That's so surprising with an exclamation mark. Suddenly you're wrong. Because 20 exclamation mark actually means 20 factorial. It means 20 times 19 times 18 times 17 times 16 and so on, all the way to 1. So be careful with exclamation marks in maths. They don't mean, they mean factorial, which is this thing we're seeing up here. Just a little side note. Right. So 1 factorial is 1, 2 factorial is 1 times 2 is 2, 3 factorial is 1 times 2 times 3, which equals 6. Use your answer to A to calculate 12 factorial. So what we must not do is work out 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10 times 11 times 12. For one thing, it's going to be an absolutely huge number, which I've got noted down here because I worked it out before the class. It's going to take you a very long time to work it out. And besides, it says use your answer to A. What is our answer to A? Our answer to A was 06. So the first 6 odd numbers multiplied together. How's that going to help us? Well, 12 factorial is, if you think about it, the first 6 odd numbers, which are 1 times 3 times 5 times 7 times 9 times 11, multiplied by the first 6 even numbers, which usefully are given to us here. So it's going to be 06 equals 12 factorial equals 06 times E6. Now we know what 06 is. We worked it out. It's 10395. 10,395. And we know what E6 is because they gave it to us. It's 46,080. Okay, so that's useful. But I should have given myself some more space. So I'm going to write it up here instead. 12 factorial equals 06 times E6, which equals that, and I'm going to use this for my working out space here. Now, to make this a little bit simpler, of course, this has got an O at the end, a 0 at the end, so I can work it out without that and then times the answer by 10, and that's going to save me a row in my already rather large multiplication. So let's do it that way. So I've got 10, oops, let's make this nice and clear. 10, 3, 9, 5, for me that's clear, times 4608, and my tablet's sliding away. Okay, now I'm going to work that out, and then I'm just going to stick a 0 on at the end to match that 0 there, and that's going to save me a bit of effort. So 8 times 5 is 40. This is why I make embarrassing mistakes. 8 times 9 is 72, so we got 76 here. 8 times 3 is 24, but we got a 7 here. 24, so we got a 7 here, so that's going to be 31. 8 times 0 is 0, so we got the 3 in there, and now we got 8. So we got 83160. Now we start the next row with a 0, but also the next row is all zeros anyway, because it's 0 times. So we don't have to worry about that. Now the next row we start with 2 zeros, and now we got 6 times 5 is 30. 6 times 9 is 54, and we got 3. Oh, I hate massive multiplications. 6 times 3 is 18, we've got 5 carried. 6 times 0 is 0, so the 2 goes in, and 6 times 1 is 6. Okay, we're almost there. So now we're starting with 3 zeros, and we got 4 times 5 is 20, which is not 20 factorial. We got 4 times 9 is 36, so it's going to be 38. We got 4 times 3 is 12, and 3 is 15. 4 times 0 is 0, so we got the 1. 4 times 1 is 4. Now we add it all up, and I cross my fingers that I've got this right. So we got 0, 6, 1, 10, 16, 17, 18, 19, 20, 5, 6, 7, 8, 9, 6, 7, and 4. And I think that's good. That's right. But now we need to times that by 10. So I'm just going to put a note for myself like that. Sloppy maths, but it saves me writing it out again in an exam. So the answer is actually 479,001,600. So 479,001,000 600. And that is 12 factorial. I said it would take a long time to work out. Sorry about my writing here. Writing on a screen is hard, and writing is hard for me, per se. Right, so that's a really horrible big multiplication, but it's an awful lot easier than trying to work out 12 factorial from scratch. We know 06, we know E6, we just need to multiply them together. And we save a little bit of effort by dealing with the times 10 at the end of E6 at the end. Right, next one here. What's the remainder when this massive row of factorials is divided by 5? So you're going to be really tempted to work all of this out and divide it by 5. But hang on, let's think about it a second. So we've got 3 factorial here. 1 times 2 times 3. Okay. But what happens if you carry that on a second? If we do 5 factorial, it's going to be 1 times 2 times 3 times 4 times 5 is something. 6 factorial is going to be, well, let's do it backwards. 5 times 4 times 3 times 2 times 1. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 7 factorial is 7 times 6 times 5 times blah, 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 8. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So all of these ones from here upwards are times by 5. So they're not going to have any remainder when divided by 5. So they are irrelevant to our calculation. So these multiples of 5, I'm going to write a note for the marker. Multiples of 5, therefore no remainder. Therefore no remainder. Those 3 dots in a triangle is a therefore symbol. Just a shorthand. So now I just need to work out the rest. And they've already given us 1 factorial, 2 factorial, and 3 factorial up here. So we know that that's 1 plus 2 plus 6. Six, 7, 8. So that's 9. 1 factorial to 2 factorial. So that's it. So all you have to work out is 4 factorial. That's it. That's the only thing we really have to work out. 4 factorial equals 4 times 3 times 2 times 1 equals 12 times 2 is 24. And now we just got to do 24 plus 9, which is 1 factorial plus 2 factorial plus 3 factorial. 24 plus 9 equals 33. So what's the remainder when that's divided by 5? 33 divided by 5 equals 30 divided by 5, which is 6. Remainder 3. So what's the remainder? It's 3. Easy as that. I just realised I wrote rubbish in my working out before the lesson. It's a good thing I didn't do that here. Oh, I hope I didn't. It's actually relatively straightforward. Now, barely anywhere here did I actually call upon any advanced maths that you've done at primary school. This is really not using your maths knowledge there particularly. Yeah, it requires you to do a long multiplication, but beyond then it requires you to know what an odd number is, what an even number is, and to know how you find a remainder. But that's all fairly basic stuff. None of that is, year 6 maths at primary school. That's mostly sort of, I don't know, year 3 or 4 maths at primary school. So none of that's very difficult. The hard thing is looking at the new maths that they've shown you, this 03, 05, E6 business, and working with that. Looking at, in part B, looking at 050 and saying, well, I'm not going to work that out. Let's look at what I've got. I've got 05. And in 05, not to lose my hand, in 05 we've got times 15 inside it because we've got times 3 times 5. Therefore, it's not going to have a remainder. That's actually some fairly basic mathematical understanding, but it's knowing when to apply it. And that's about being relaxed in the exam and thinking around the possibilities, seeing immediately that they're not going to ask you to work out 050. That would be ridiculous. But how can you work around it and think rationally? And then you've got this new idea, factorials. Some of you might have come across factorials before, but most of you won't have done. That doesn't matter. They tell you what they are. How can you then work with that in a calm, logical way? If you can do that, then the world will be yours. But that's the challenge with this kind of thing. All right, thank you very much. S. Pillai in the comments. Hi, Robert, you are a very nice tutor. I'm most flattered. I don't want to be nice. I want to be effective. I want to beat you into brilliance. But never mind, you're probably beyond hope, but I'm delighted to be at least pretending to teach you. I'm joking. You're all very smart. I know it. Shika says, I will go to Tiffin Boys. I will. Maybe that means you've got in. In that case, many, many congratulations. Absolutely fantastic school. And well done to everybody. I'm going to Latimer. I wanted to go to Tunbridge, but I got something. Hey, you got something else. That's fantastic. To get anywhere in the 11 plus is amazing. Someone says they've gotten to Tiffin. I mean, look, these are all brilliant, but I'm especially flattered that those of you who have already passed your 11 plus are turning up here to learn more things. That's amazing. It means you're absolutely amazing students. It means that you're the kind of people who are going to do brilliantly at secondary school. The fact that you would spend your Tuesday evening doing this. But maybe it's just because my lessons become so short, because indeed they have. Learn Math says, good to see you, Robert. This is my first live lesson. A huge welcome. I hope it won't be your last. Really wonderful to see you. All right, I'm going to log off in a second because I have to go and prepare my Zoom class in which we're looking at some creative writing. And if you want to join one of my classes, have a look at the links in the video description. You can join your first class for free to try it out. And there's information about how to do that on my tuition page on my website. All right, everybody, it has been an absolute pleasure, at least for me, if not for you. And I hope you have a lovely rest of your Tuesday evening and a wonderful rest of the week and a beautiful weekend. And that's enough extravagant language from me. At least for you, I'm going to go and serve up my extravagance to somebody else. Look forward to seeing you in another lesson very soon, and I hope that was useful.